Okay, so the other part of our lesson for factoring polynomial expressions is 3.1. So that ties to 3.1 in your workbook. So there's going to be some practice questions that you can try with that. So example 1 is looking at just factoring general quadratic expressions similar to what you were doing in the previous part of this lesson. So remember that step 1 is looking for your greatest common factor. So in this case, I see 2, 2, and 12, so I can actually take that out of all of them. So I'm going to end up with x squared minus x minus 4. From there, I identify the type of polynomial. And specifically, am I dealing with complex? Am I dealing with simple? Or am I dealing with a difference of squares? Okay, because this is a simple trinomial, we're going to break it up, and again, we look for product and sum. So two numbers that multiply to give me -4 and add to give me -1. Well, the only factors for 4 are either 1 and 4 and 2 and 2. And in no scenario can this happen. So we would say that this part, our trinomial there, is prime. And so we're actually just dealing with the 2 and then x squared minus x minus 4. And then we were done. So we wouldn't say that the whole thing is prime because it's not. I was able to factor it a bit, but not any farther than that. Now here I'm dealing with a decimal, which is not always our most optimal piece to be dealing with, but I can actually factor a decimal out. So if I want to take out a decimal, I'm just going to tell which decimal place I want to take. And then I am left with, instead of 1, I would have to multiply 10 by 0.1 to equal 1. X squared, and then plus 14x minus 12. From here, okay, and if you're not sure about that one, just think about, okay, 0.1 times 10 gives me 1. 0.1 times 14 gives me 1.4, and so forth. Okay. From here, I'm going to check, and I have a greatest common factor here actually of 2. So I'm left with 5x squared plus 7x minus 6. So I factored and I factored again. Now if you could have spotted that you wanted to take 0.2 out from the beginning, good on you. I usually just try and get rid of my decimals and then I deal with everything else. It's just a personal preference. Okay, these two pieces together, because they're just two numbers multiplying, can be put together, so 0.2. But otherwise I'm dealing with 5x squared plus 7x minus 6, which is a complex. So I'm just going to work with it on the right-hand side here. And so using my crisscross method, I've got 5x times x. And I need to somehow get to 7. I need to be subtracting here. So maybe if I have positive 2 and negative 3 to give me 6. So let's check it out. We've got negative 3x and 10x would give me my positive 7x. Oops, what's going on here? Okay, so it gives me my middle term. This does in fact give me 5x squared. This gives me -6, so that all works out. That means that this is one bracket, this is my other bracket. Okay, and that would be my final answer. Next one, fractions. Yay, fractions. We love fractions. maybe not so much. Okay, we would want to factor it out just like any other time. So 1/4, we need to multiply by 1 to get 1/4. So that stays like it is. What would we have to multiply by to get 1 if we're using 1/4 times what equals 1? How many 1/4 goes into 1? That would be 4. And how many quarters go into 3 wholes? Would be, if we think about it as 3 wholes, 1, 2, 3 wholes divided into 4 pieces, that's 12. Okay, from here it's a simple trinomial though, and I'm looking at two numbers that multiply to give me 12 and add, -12, sorry, add to give me -4, so that's going to be -6 and +2. They need to be the same set of numbers for both, just as a reminder. So I've got 1/4 x minus 6, x plus 2, and I'm done. So yeah, just factor out that fraction. If you need to draw it out, this is 3 wholes, and it's also 12 quarters. Okay. So let's try this one, factoring out a half. We're left with x squared minus 2x minus 8. Again, simple polynomial from there. We end up with x minus 4, x plus 2. Okay, so example 2 looks a little bit more complicated than what we've seen so far. The only difference is that we're dealing with this stuff inside the brackets. To start with, we're going to ignore that stuff inside the brackets. So you can either deal with it there like it is, or you can say, let all that stuff that's inside the brackets actually be represented by something else. So we can use y, you could use m for something completely different. Okay, so then I could say this is actually like 12m squared plus 24m plus 9. Well, that looks more manageable. That looks like a polynomial we've been working with so far. From here, greatest common factor is 3. So we're left with 4m squared plus 8m plus 3. We're going to have to factor that. That's a complex. I'm going to keep those m's red for now, just so we remember that they're kind of out of the ordinary. So I've got 4 and 3. I'm going to do the matrix version this time, pretty similar. So I need 4m squared to show up, and I need +3. So it could be 2m and 2m and 3 and 1 maybe. Let's try that out. This would be 6m plus 2m. Well, that gives me 8m, so that works out lovely. So those are my two factors. 2m plus 3 and 2m plus 1. But I'm not done here because those m's are not actually part of my original question. I put them in there, so I got to take them back out. So what actually is it's 3 times 2, x plus 2 goes back in for m plus 3. So I switched to square brackets on the outside. You could have double rounded brackets, that's totally fine. You're more than welcome to do that. I just like to have only one kind of each if possible, or alternating, so that I don't get them confused. From here, I'm gonna have to do a little bit of expanding, a little bit of distribution, a little bit of FOIL, however you want to think about it. And so I end up with 2x plus 4 plus 3 and 2x plus 4 plus 1. Am I done? Not yet, because I've actually got some like terms within those brackets. So I've got 3, 2x plus 7, 2x plus 5. Now you want to be super, super careful, okay? So when we're looking at this, you're only looking for like terms within the brackets. Because remember, order of operations says brackets, exponents, division, multiplication, addition, subtraction. These like terms can only happen within or if there are no brackets. So let's try this one. Again, I'm going to substitute in another letter because it just makes my life a little easier. So it's going to be 3x minus 4, going to be represented by a in this case. So I'm going to have 6a squared minus 21a plus 15. Again, common factors. Divided by 3 is 7, 15 is 5. Again, I'm dealing with a complex trinomial. So I'm going to do it my third way now. So I've got 2a squared minus 7a plus 5. Looking for 10. Factors like negative 7, so that's negative 5 and negative 2. So I'm going to break it up. 2a squared minus 2a. Imagine it's cut in half. Notice I take out the full negative 5 from this first one, which changes my sign of my second term as well. So I was doing with a minus 1 and 2a minus 5. So that's what I have here. But again, those a's need to get replaced. So I'm going to skip that step. Since I've already got my factored piece written out over on the right-hand side, I'm going to kind of kill two birds with one stone. Instead, I've got 3x minus 4 minus 1 and 2 times 3x minus 4 minus 5. Okay, so those red pieces are coming from over here. Okay, from here it's going to be expand and collect like terms. And so my final answer is going to be 3x minus 5 in this set of brackets. And 6x minus 8 minus another 5 is going to be negative 13, minus 13. And that would be my final answer. Okay, so I know this is getting a little bit more complicated. Please do some practice questions. I really do recommend this substitution method as long as you remember to plug back in. Okay, our third example here is looking at solving quadratics that are differences of squares. So again, differences of squares requires that we have two perfect squares and they are subtracting. So our first term in example A is pretty easy to spot. So we talk about the square root of 9 is 3, the square root of x is, or x squared is x. The square root of 0.64 is actually 0.8. Okay, because 64 is, the square root of 64 is 8, and then we've got some decimal relationships there. Okay, and the square root of y. So we can do it that way. Alternately, if you didn't spot that right away, you could have done it how we did before dealing with decimals. You could have factored out a 0.1 and then left it as 90, but now that's not a perfect square. Okay, so that's not really a very good option. This way is better. So 64, spotted as a perfect square. If you're not 100%, you will have access to your calculator if you're dealing with a decimal like that. So please go ahead and use it. Second one, just because it's in the denominator doesn't mean it's not a perfect square. So in this case, we're dealing with x over 3 as our first term in both brackets. We're dealing with 2 over 5 as our second term in both brackets. It's just opposite signs. And that's it. That's all I have to do. Ta-da! Okay. So when we get to C, same principles apply. D, same principles apply. We're just doing a little bit of both. Now we're taking those first steps of dealing with perfect squares and also dealing with binomials within polynomials. So this is a perfect square. So I'm going to use square brackets around this. And I've got 2x minus 1 and 2x minus 1. My square root over here is y plus 4. And then I just do opposite signs. But I'm not done here because I can collect like terms within brackets. Don't forget your equal sign out in front. Okay, don't have like a running line of a bunch of equal signs. Don't do that. Bad. Not real math sentences if we do that. Okay, so then this first set of brackets, I've got 2x, no other x terms, so that stays the same. Minus 1 plus 4 is going to be positive 3. But before I do that, I'm going to write my other variable as well. My second set of terms, this negative actually applies into the brackets. The positive applied here, but it doesn't change any signs. So I've got, again, 2x. This time I'm subtracting y though, and I've got 1 minus 4 is negative 5. So that would be my final answer. I would have to try to collect as many like terms as possible. Last, or second last one? Second last one? Yeah, almost there, guys. Okay, same properties still apply. If you need to substitute in and think like that first, call this R and Q or something, go ahead. Actually, I'll do that for this one. So I've got 3R plus and minus 2Q and 2Q. But because this is happening so quickly and the difference of squares factors come pretty easily, I don't usually like to do that step just because it's just an extra step. But if you need to, go ahead. 3 times 2t plus 1, so plugging back in for R, plus 2, s minus 2 is in for q, and then we've got 2t plus 1 minus 2 times s minus 2. Okay, so make sure you're plugging them in back correctly. Don't lose those coefficients out in front. 2 is still there, 2 is still here, 3's are still there. Okay, always double check that we're not dropping anything. Opposite signs still happen. Okay, we're going to expand from here. 6t plus 3 plus 2s minus 4. 6t plus 3 minus 2s plus 4. Okay, and notice how my signs are different on those second term or those later terms because of that difference in sign within my binomials. Last step, collect like terms within the brackets. So I've got 6t plus 2s minus 1 and 6t minus 2s, and that's plus 3 and plus 4 is plus 7. Okay, so only collect terms within brackets. Okay. Last one. Almost there. We're so close. Well, 32 and 18 are not perfect squares. Crap, what are we supposed to do? Oh wait, that's not the first step actually. My first step, if I go way back up here, is, oh, it's way back here. Greatest common factor. So, if it doesn't look like a perfect square exactly, but we got where we've got a binomial with otherwise squared pieces, and they're subtracting, well, maybe we can turn this into a difference of squares. So we can take out a 2 from both of those. And we're left with 16x plus 2 squared minus 9, 2y minus 3 squared. From there, well, 16 is a perfect square, x plus 2 squared is a perfect square, 9 is a perfect square, so is this piece here, 2y minus 3 squared. So I'm dealing with a difference of squares. So let's go ahead and break this down a little further. This leaves me with 4x plus 2 is my square root of my first term. The square root of my second term is going to be 3 times 2y minus 3. Okay, and then just opposite signs. I'm going to distribute and collect like terms. So again, I'm going to skip that actual writing out of that step because it's going to take up the whole width of my screen. Okay, so 4x, no other x terms in that bracket, so I'm just going to have 4x. We've got 8 minus 9 is minus 1, but I like my variables all together, so it's going to be 6y first. Second set, 4x minus 6y, because of that negative out front here. And then 8 plus 9 is going to be 17. Okay, and I am done here. Now, you might be like, but 4 and 6 have a common factor, Miss Conrad. Like, did we miss something? No, we didn't, because the third term doesn't have a common factor with the other two. So we can't take it out of just 2 of the 3 terms. It would need to come out of all 3. So we are, in fact, done. So there's lots of practice questions for you to try. You want to ace factoring. Like I said, we're going to see it a number of times in assessments. And if you can't factor at like 75% or higher, you probably shouldn't be taking grade 12 pre-cal. So we want to master this. So practice, practice, practice. And tomorrow you'll be able to ask some questions in class.